All right, once you put all distractions away, earbuds, phones, all that stuff, be away, please close up the Chromebooks and look at a couple things real quick here. Okay, awesome. Thank you. Okay, so from yesterday, we talked about how to solve sort of, I mean, some of them are kind of challenging questions, linear equations, but involving fractions, and there's, a lot of, probably the more complicated steps are the ones that revolve around trying to deal with fractions, right? So we did really the hard stuff, I think, from section 1.3. Now we're going to fill in some of the gaps a little bit. Let's look at a couple different specific kinds of problems. They're easy problems to solve. The algebra is easy, but the results are a little strange. We want to look at how we're going to interpret what happens with these. So, what about this top one? Can you point to a single variable in the top one, or do you see multiple variables? Multiple. We got 3 C's up there, right? So we're going to have to go back to our strategy. Before we can isolate, we're going to have to simplify, right? So we're going to simplify first, all right? So let's just go through the checklist here. Inside the parentheses, there's one set of parentheses, but there's nothing inside we can do to simplify, right? So we can check that one off. There are no exponents, so we can check that one off. There is a little multiplication. What do we have to do? What kind of multiplication do we have to do to simplify here? Distribute. Yeah, I got to multiply the 5 times this quantity. So we can distribute. Good. Now what? What about the add subtract? Okay, good. We can combine some like terms. Negative 5C plus 8C is 3C. Okay, good. And we still have multiple C's. What's the next step? There's where it starts to get weird. Okay, that's where we normally get the variables on one side, isn't it? By adding or subtracting C's from both sides. But what's going to happen here? I have 3C on both sides. So when I subtract, I go ahead and subtract 3C from both sides to simplify things. Well, what happens? I end up with the 3 C's canceling. I just get a 1, and the 3 C's canceling, and I just get a 5. 1 equals 5. What's that mean? No solutions, yeah. So if we're solving an equation and all the variables disappear, and we end up getting a nonsense answer, an answer that's not true, then that's the math god's way of telling us that there's no solution. There's no value of C that I could plug into that equation and make it work. Okay? So in Moodle, what are the instructions there? What do they tell you to do? Yeah, they tell you to just enter a capital N. Now, it's not a fancy N. It's just a capital N from the keyboard. That's it. Okay? What about this next one? Same kind of thing. We'll zip through this a little faster. So I could distribute the negative 8, right? If I distribute the negative 8, we're going to get 40 minus 8x equals, I'm going to get a negative 8x, and negative times negative is positive, so I get a plus 40. Just like before, we could get rid of the x's. I could add 8x to both sides. So the 8x's cancel. Well, look what happens this time. I end up on the left side with a 40. On the right side, the 8x's cancel, and I get a 40. What do you suppose that means? If the variables go away, and I end up with a true statement, what is it again? All reals. Any number will do. Any real number that I plug in for x in my original equation is guaranteed to work. Doesn't matter which one. So in Moodle, the way we enter that is with that double struck R. That represents the set of all real numbers. On this assignment, you don't have to go find that. You can just plug in a capital R and it works. But just be aware that in the future, I can't guarantee I will have done that for all assignments. In the future, you might have to put in the actual double struck R. So where do you find that? I'm going to show you in Moodle. Did I show this to you yesterday? No. Okay, let me show this to you.
Unlike written assignments, do you want us to do that, R?
If it's saying for all reals, if it tells you to, it's just that these questions. I built these questions over so many years. They're not in that. Sometimes they'll say just capital R, and sometimes they might say to go find that weird one. I'll show you where the weird one is, just in case you need to find it. It's really not that hard to find. So if I just go into any sample question here. When you go into this algebra, the answer box here, this algebra editor, it allows you to enter all these, square roots and cube roots and all this fancy algebra notation. You'll notice that there's little triangles. When you look at this closely when you're on Moodle, there's little triangles down here. Those little triangles always mean that's a drop-down menu. So if I click on the triangle, I get some other options for grouping symbols, for example. Okay. Well, if you go over to the operations menu, this is the division sign. I can see a bunch of stuff in there, and there's a couple of these that are important. I don't really care so much about the time signs. These are going to end up being important, the and or operators. We'll get to that later. But right away, we're going to need this less than or equal to and greater than or equal to sign. It'll be after roundup, but when we start talking about solving inequalities, which comes up pretty quickly, you can find the less than or equal to signs right on the keyboard, but when you want to include the equal sign with the less than or the greater than signs, you have to pull them down from there. And here's, if you go to the number menu with the pi on it, you'll see that when you look in there, there's an I for that. That'll be important to us later in the year, that I. There's infinity symbols. You might need those at some point later. And along the bottom, there's all the sets of real numbers that we talked about. The double struck N is the natural numbers. If you hover over that, you can see the Z is the integers. Q would be the rational numbers, like we said. And there's the R for real numbers right there. If I click that one, see it shows up as kind of a fancy double struck R. It's blue, it's not black. Okay, that's where you find it if you need it. Okay. Not on this assignment, I don't think you do, but in the future you may. Okay, so moving on now, the next issue is what we call literal equations. Literal equations are just equations that involve more than one variable, right? All the equations we've dealt with up until this point, we've only had one kind of variable in each equation. Maybe it's an X, maybe it's an R, maybe it's a C. But we're able to solve for, if I go back, we're able to solve for, is that one we did? No, we didn't finish that one. Where's one that we finished? Right there. So we had an equation where we solved for X. At the very end, we got X equals some number because there were only X's in the original equation. So I was able to isolate that X and get numbers on the other side, right? Okay, when we move up to these literal equations, that's not going to be the case. These literal equations, like here's an example, we get W's and V's in our original equation, right? So if they tell us to solve this equation for V, is it surprising to you that I'm going to get W's in my answer? If I isolate the V and push everything to the other side, well, there are W's in that equation, right? So I might end up getting W's in my answer. That's fine. That's fine. We're just solving for one variable in terms of another one. So let's talk about this then. Let's just go through the steps. What you're going to see is, this isn't hard. It's no harder and probably easier than the other problems you did. It's just different, right? So if we're trying to isolate, well, can we point to a single V up here? Yeah, we can. It's right there, isn't it? Right, there's my V. If I want to isolate that V, if I can point to a single variable, I can isolate it by reversing the order of operations. So all we have to do is just go backwards to our order of operation tree, just inverse operations we call it, to isolate. So let's start at the bottom. So notice we don't get to parentheses until clear up there, right? So outside of parentheses, is there any addition or subtraction that I have to do to move everything away from the V? Everybody agree there is not. The only addition we see is inside a set of parentheses. So we don't get to there until we get up to the P, right? And this whole process, you've probably noticed this whole process of trying to isolate a variable really just means that we're pushing everything else to the other side of the equation, right? So we can skip through this step, nothing there. Multiplication or division. Is there any multiplication or division that I have to undo up here to get that v by itself? What do you see? The fraction, yeah, look, outside of parentheses, a 1/2 is being multiplied on this side, isn't it? Everybody agree? So how do we undo multiplying by 1/2? And you might say divide by 1/2, which is technically correct, but we don't really like to divide by fractions. What do we do instead?
Multiply by 2.
Multiply by the reciprocal, right? So we'll multiply each side by the reciprocal of 1/2, which is 2. Okay, so on this step right here then, that involves multiplying. Remember, there are parentheses. Kind of got obscured, but there are parentheses. Whoops. There are parentheses there, right? So we're going to multiply both sides of the equation by 2. You know, on the right side, what does that accomplish? How many factors are there being multiplied? Factors are the things that are multiplied. Let's count them on the right side. 1, 2, 3 factors, right? Multiplying 3 things together. I have to multiply things in pairs, but if we go back to our properties, the associative property for multiplication says I can multiply them in any order I want to. So what's the smart order to multiply those 3 things together in? What do I want to multiply first? 2 times 1/2, right? That's why we picked the 2, isn't it? So we'll multiply the 2 times the 1/2, and they cancel. That's the point. So then on the left side of the equation, 2 times 7w is just 14w, right? And on the right side, the 2 and the 1/2 go away, and now I've got a set of parentheses, and inside the parentheses, I've got my w plus v, right? So next step. Well, there's no exponent, so we can cancel that step. And finally, I get to the parentheses. Do I even need the parentheses anymore, though? No, nothing's being distributed, so I can just get rid of them now, right? So the last step to get the v by itself?
Move the W
Yeah, move the w, and that'd be by subtraction, wouldn't it? Right? I'll subtract w to the other side. And we get 13w equals v. So there's our answer. V equals 13w. So when we solve for v, I'm getting w's in my answer, but that's okay. We knew we were going to from the start. Let's try another one. Questions on that first? Okay? How about something like this? Now we're going to solve for b. Take a second. Think about what we're going to do here. First question is always, do I need to simplify, or can I point to a single b? Can I point to a single b? Yeah, I can. Right, so there's no need for me to simplify anything here. There it is. That's what I'm trying to isolate. So we'll just do inverse operations. Okay, what's first? Are there any parentheses here, first of all? There aren't any written, but are there any implied?
Yeah.
Where? Direct.
Like the isn't the fraction bar right there a grouping symbol?
The fraction symbol separates the top and the bottom, but if there's more than one thing in the top and the bottom, then there's implied parentheses around the numerator and the denominator. I don't need them in the denominator because there's only one thing. But even though I don't need to write these, but I need to just recognize that they're there. The a plus b is really grouped, isn't it? Because it's everything that's above the fraction bar. Okay? So now, what are the steps? Anything to add or subtract outside of the fractions? Outside of the grouping symbols? Nope. Cancel it. Multiplication or division. I'm trying to get the b by itself on the left side of the equation.
Yeah.
What do I need to multiply by? C. Yeah, look, I'm dividing by c. How do I undo dividing by c? I multiply by c. Right? Multiplication and division are inverse operations. They undo each other just like subtraction and addition do. We all know that. So I'm going to multiply each side by c, and the c's cancel from the left side. That's good. So then that leaves us with A plus B in parentheses, but I don't even need the parentheses anymore, right? Equals 5C. What's the last step to get that B by itself? Yeah, good, subtract A. And we get B equals 5C minus A. Right? Okay, we solved for B, we got C's and E's in our answer, or C's and A's in our answer, that's okay. All right, so you'll get some practice with those. The other thing I wanted to look at, and there's nothing new here. There's nothing that you don't already know. You've done this stuff. There's no new algebra to think about. But dealing with some word problems. Okay, now, let's take a poll here. How many people would prefer doing a regular algebra problem to a word problem? Raise your hand. Everybody. Guaranteed, right? Word problems just seem pretty hard. They just make you cringe. They seem pretty hard because the math is disguised. But I'll tell you, here's the good news about word problems. The good news is, and I teach all levels of math, the good news is that word problems, even though you got to go through that additional step of turning it into an algebra equation, once you get to the math, it's every time the math is always easier. It's like the people that write the problems feel like, you know, if you can get it into an equation, there you've done your job. The math is never going to be that hard. And the issue is getting it into the form of an equation. And this just takes a little practice. It really does. There's some tricks and some patterns you can look for. Certain words are easy to recognize as having mathematical meaning. Okay? Like, for example, the word is. And that shows up in a word problem. What's that always correspond to? Equals. Yeah, you know it every time, right? When we talk about a product just means multiplication, right? If we say increased by, what am I doing? Added, right? You're getting the idea. Okay, so we want to see if we can take this step by step here, and let's just kind of go through this process together so you can get more comfortable with the thinking. That's my only goal here. Okay. Well, they want us to find the number before we go anywhere. I mean, the number, that's the unknown, isn't it? Right? The thing we're trying to find. You know, word problem, if they ask you to find something that's known, it's not much of a word problem. You can just write the answer down. It's only really worth doing, or a math problem of any importance, if we're trying to find something that's not given to us directly, trying to find an unknown. What do we always do with a math problem, with a word problem? What do we assign to the unknown? Some variable, whatever you want. Probably X is the one we're most used to, right? So we'll just say right away that whatever the number is, we're just going to call that X out loud, right? So let's take these statements one at a time. Let's take the first one. The product of 7 and a number increased by 3 is the first part. Is, or is equal to, in this case, they actually say is equal to. And then we get the other part, twice the number subtracted from 39. So that looks an awful lot like an equation, doesn't it? We're going to get a certain expression, the orange expression equals the blue expression. So we just have to turn that stuff into math, and that's not so bad. The product of 7 and a number, how do I say that? 7x. There you go. So, whoops, wrong color. 7x increased by 3 plus 3 is equal to, so equals, what about this one? Twice the number subtracted from 39.
39 minus 2x.
Oh, that's it. Now that's a pretty easy problem to do, isn't it? Then you put you do the work up front to set up the equation, but then the equation is not very hard. Right? We could combine like terms and solve for x there, no problem. Agreed? Okay? Let's skip up to another one so I get you going on some practice. How about this? The sum of 4 consecutive integers is 222. So, you know, this part's pretty simple. We get the is, there's my equal sign, 222. Well, that part's easy. The first part is the part that maybe we got to think about a little bit. The sum of 4 consecutive integers. Well, what's the word consecutive mean? Say it again.
They're scaling up.
Scaling up by 1. Yeah, just so in a row, so to speak. So integers, 4 consecutive integers. A set of integers, what's that again? Negative or positive whole numbers, okay. So somebody throw out an example of 4 consecutive integers. 1, 2, 3, 4. There you go. 10, 11, 12, 13, something like that, right? So how are we going to do this then? So what's our unknown? It says find the integers. So here's where we got to maybe think about how we're going to structure this a little bit. Because we have a couple options. We could, for 4 integers, we could introduce 4 different variables. Like we could let W be, or A be the first one, B be the second one, C be the third one, and D be the fourth one. We could do that, but that's hard. The more variables I introduce, the harder the problem gets, right? So is there a way that we could do this maybe in terms of just a single variable? Like if we wanted to make a list here, let's say the first integer what could we call that maybe? And we don't know what it is, but x, how about, right? If the first integer is x, then what would the second equal? Ah, there you go, right? So we only need one variable if we're tricky about this. The second integer would just be x plus 1. The third would be x plus 2. And the fourth equals x plus 3. There you go, right? And so now our equation, if we use those values, our equation would just be x plus 1 plus x plus 2 plus x plus 3 equals 222. There's the sum of my 4 consecutive integers, right? Do I really need those parentheses? Nothing's being distributed, right? Why are they there? Well, it helps us organize our thinking because it reminds us that this is really the first, second, third, and fourth integers. But other than helping us see this, they don't really do anything, do they? So we could get rid of the parentheses and just add like terms. So on the left side, how many x's am I adding up? X plus x plus x plus x, so I get a 4x, and then what if I add like terms? 1 plus 2 plus 3 is no big deal, right? We can do this. So what are the steps to get the x by itself? Subtract 6, and we get 4x equals 216. Divide by 4, and we get x equals 54. So is that our answer? Kind of, but what was the question, the word problem actually asking? So here's the last part of this when you do a word problem. You're kind of going to go from real world English mode, you're going to flip the switch and go into math mode. You're just going to do some algebra, you're going to get an answer, but then you have to kind of reverse that. You have to go back from math mode into real world situation. So you have to interpret your answer in terms of the question that's being asked. They want to know, find the integers. Well, x is the first integer, right? So what would my answer really be then? It wants all 4 integers, so 54, 55, 56, 57. There you go, right? And in Moodle, what you would do it always says if there's multiple answers, just separate your answers with commas. So we just enter it like that. Okay? Questions? Good? All right. This is a good bunch. I feel like this group really, you guys seem to get this stuff pretty easy. Okay, last one. The length of a rectangle is 1 more than 4 times its width. If the perimeter of the rectangle is 62 meters, find the dimensions of the rectangle. So when you're doing geometry problems like this, a picture really helps organize things. So let's draw, first of all, let's draw a rectangle. There's my rectangle, okay? Okay, there's my rectangle. Whoops. So it says the length is 1 more than 4 times the width. So what do we want to call? What do we want to call the width, maybe? Whatever you want, doesn't matter. X maybe? Okay, so the width we'll call X. So then that dimension right there we'll call the width, that's X. So if the width is X, how do I say this? Width is X. How do I say the length of a rectangle is one more than 4 times its width? One more than 4 times its width. The width is X. So how do I say mathematically one more than 4 times the width?
Or x plus 1.
4x plus 1, right? Everybody see that? Okay? And all they want to know is, if the perimeter is 62, find the dimensions of the rectangle. So what's our formula, really quick, just kind of geometry review. For a rectangle, what's area equal to? Length times width. Okay, what's perimeter equal to? What is perimeter? What is it again?
Or is it length square plus?
No. Just think what it means, first of all. What does it mean in terms of the picture of a rectangle? Good, the distance around. So it's a sum of all the sides. So how many lengths do you have and how many widths? 2 and 2. Okay, so the perimeter is just 2L plus 2W, 2 lengths and 2 widths go all the way around. So the perimeter then equals 62, right? So we can set up the equation, the sum of the length and the width. So 2 times x plus 2 times the length, which is 4x plus 1, must equal 62. How about that? Now I've got an equation that's pretty easy to solve. I've only got one variable in there, right? So what would I do? I've got 2 x's. I've got to simplify first before I can isolate. What do I need to do to simplify? Distribute, good. Got to distribute the 2. So that gives me 2x plus 8x plus 2 if I distribute, right? Equals 62. Now what? Combine like terms. 2x plus 8x is 10x. Plus 2 equals 60. Now I got a single x I can isolate. What are the 2 steps in order to isolate x? First
Isn't it supposed to be 62?
oh, you're right. I was thinking ahead 1 step, wasn't I? What do I do first?
Subtract 2.
Subtract 2. Good. So I get 10x equals what? 60. Then what? Divide by 10, so I get x equals 6. Is that my answer?
No.
No, they want me to find both dimensions. So the width is 6. What's the length going to be?
4 times 6 plus 1.
Yeah, 4 times 6 plus 1, which would be what? 24 plus 1 is 25. Yeah. So there's my dimensions. 6 by 25. Okay. Get it? I think you guys are doing well on this. Okay, last one. Let's just set this up. We won't even do it, but I just want to point out that sometimes there's some implied relationships here. So it says the measure of the vertex angle in an isosceles triangle. Let's go back to geometry real quick. What's the definition of an isosceles triangle? Say it again. 2 angles are congruent, and that's kind of a secondary thing, but the definition is the triangle has two sides that are congruent, and that tells us that the base angles are congruent also. But it's a triangle in which exactly 2 sides are congruent, right? Actually, it's a triangle in which at least 2 sides are congruent. Sometimes people keep textbooks do that wrong sometimes. So technically, an equilateral triangle actually is isosceles too. It's got at least 2 congruent sides. But we won't go there. That's not important for now. So in this case, it's important to know that 2 angles are the same, right? The measure of the vertex angle. Let's just draw a quick picture of an isosceles triangle. So these 2 angles would be congruent, right? Here's the vertex angle. the vertex angle is 6 less than 4 times the measure of a base angle. Okay? So if I call a base angle x, what's the vertex angle going to be then? How do I say that? How do I say the vertex angle is 6 less than 4 times the measure of a base angle? If the base angle is x,
4x minus 6.
4x minus 6. Everybody agree? So this angle up here is 4x minus 6 degrees, right? Okay? Good. But how do I solve for x? I need to come up with an equation somehow. Nowhere do they set up the equation for me. How could I use my knowledge about triangles to come up with an equation here? Suggestion?
2x plus 4x minus 6 equals 180.
Ah, okay, there's the key. The sum of all the interior angles in a triangle is always 180, isn't it? Right. So we know if we added all 3 of those up, we're going to get 2x plus 4x minus 6. We know it has to add up to 180. Now I could combine like terms and solve for x, right? And once I know what x is, I know what the base angles are, and I could plug that value in up here to find the vertex angle. You guys see that? Okay? I'm going to let you work. Let you work. So grab your Chromebooks if you don't already have them. Get logged in.